Alright, welcome back. So today let's continue working on Scufris. And since the last time I did a few minor things like tweaks on Scufris, I added better like verbose dialogue between the agents. So now we can see what Scufris says, and instead of just saying, okay, I'm gonna call the tool, I'm also showing the name of which agent Scufris is calling, and then the prompt itself, and also the knowledge agent then says something. And right now you're looking at an example where I asked what is the capital of France. Then I'm using Quen3 as the supervisor, and Quen3 has better tooling from what I've seen, and it also has thinking just like DeepSeek. And then for knowledge, I think I'm still using Llama 3, but it's just supposed to create a query for the web search tool. And here you can see that the Scufris agent figures out that it has to ask the knowledge agent for some information. Then the knowledge agent is calling the web search tool, and it's finding this Wikipedia page. And then knowledge responds with the information that Scufris asked for, and then Scufris responds with the final response. We might want to tweak a bit the CLI, like the REPL tool is basically a REPL tool, to remove the thinking tags on the final message. But right now it's just IO, like really simple printf, scanf, basically for the final text and the user messages. Okay, so that's basically all. I guess I opened some stuff. Okay, whatever. So I guess that's all that Scufris does right now. It's able to call tools, and we have the entire list of tools here. But what I was saying would be interesting to add some other tools. Like, for instance, maybe in the future we'll do web scraping or parsing files. But for today, what I thought would be maybe interesting to do is to add image generation. And yeah, I struggled a bit to make it work because it was, I don't know why Python is so difficult to use on Nix. It's like really annoying. I guess that's why I'm doing C and Golang, but yeah, not sure why it's that annoying, but I was trying to implement image generation in Python because I'm not sure we have like stable diffusion and other things in Golang. I mean, we have Ollama, but I'm not sure there is something similar to Ollama that you can use for image generation. So I decided to implement my own really simple API that's just going to use Hugging Face diffusers to just run like a pipeline, like stable diffusion, Excel. And I had to do it in Python because Hugging Face is implemented in Python. I can go through the code a bit because it's really short. So what I did was to use FastAPI for having like a really simple API interface to expose this generate router. Then we load the stable diffusion model. I just copy pasted it basically from here. You just have to copy paste it. That's all I'm gonna say. You just copy paste it from there, and then inside of this route, I called it. I changed the number of inference steps to 20 because 50, it has 50 by default, and it was taking a bit too long. Now it's just 10 seconds, much better than I think it was 30 seconds. We don't have time to wait that long, but yeah. Okay, then I just returned the image as a image/png. So what we can actually do is go to /docs if we run this thing, and I decided to run it with Docker because again it was way too painful. I'm not sure why this painful on Nix, but I couldn't get the packages to install. It was like I waited a couple hours and it was just compiling them, like so annoying. I'm not sure what I did wrong here, but I was like, okay, I know that I did this thing on Ubuntu like a long time ago, so I just decided to do a Docker file. I'm not sure what I guess it's Ubuntu because or Debian because it's using apt-get. But you know, I just said okay, let's use like the PyTorch Docker file, like the PyTorch base image, and then just install the requirements from a requirements.txt instead of from a flake. And I guess this one was useless. I was trying to install it with virtual environment, but whatever. And then we just run a simple file. So, you know, maybe it would have been interesting if I managed to get, but I was like, okay, I'm gonna try to install these things. Didn't work, so I scraped that part of the video basically. So yeah, I mean, this was just copy pasting it, so whatever. And I guess I'll upload this repo just in case you're curious how to build the Docker image and how to run it. But you'll need a GPU for it, so yeah. And you also need to install Docker with GPU. I guess on Nix that is pretty easy to do. I guess some things are easy to do on Nix, but some other things like using Python, it's annoying. So to enable Docker with GPU, you have to add this line. Hardware NVIDIA container toolkit enable. I'm not sure. So pretty easy to do, I guess. Okay, so if we go back to image generation, I mean, we already have an example. I just copy pasted and tried it. It generates a decent image, I guess. So the plan for today would be to add this, add a client, and that client would send a prompt and it would receive an image. So, you know, we could have done this even with like not a self-hosted tool, but it can be anything, like even DALL-E from OpenAI, like you can put the URL there, but we'll do it with localhost for now. Okay, so let's go back to Scufris and let's go I guess weather. I mean, I guess weather just did everything in here. I was just thinking that maybe we want to abstract it a bit more, but sure, we can do the same thing as we did with the LLM, but for this image. So with the LLM, we had LLM as a interface with a chat method. So we can have something similar, but it's going to be called image generation, and it's going to have a generate method. I guess that makes sense. And then we'll have an implementation for it like we did with Olama, but it's gonna be for stable diffusion. It doesn't really matter that it's stable diffusion, so we might not even care that much. Okay, so then let's go into internal. Let's add it as an internal thing, and let's call it image gen. I mean, it looks a bit weird, the name, but let's just call it image. It's like image stuff. Image.go. So it's going to be in the package image. I think that's how I did it here. Yeah, okay. So package image, and we can steal stuff from the tool. Or I guess we could just copy paste this tool, call it image, and then try to implement the image tool. So we are going to have an image tool parameters, which is going to be the prompt. So the prompt, sorry for flashbang you from like every 5 seconds, but it is what it, oh, I mean, I have an idea. Right, so now I mean, it's harder to see, honestly, with Dark Reader, but at least it's not flash banging. Nice. So we have the prompt in the image tool, right? With the prompt, we can I think I had description. Just a second. I wanted to. Okay, nice. So I wanted to use the same description as I did here. Okay, so we have the description of what the prompt does. Let's have image. And here we can say the prompt cannot be empty. Okay, perfect. And the image tool, again, we might just want to keep it simple and implement everything here, like HTTP client. So we have something easy. New image tool is gonna return an image tool. And for the base URL, I'm actually gonna have a string in here. Right now it's running on localhost 8000 and the endpoint is /generate. So again, that's mainly the reason why I wanted to have it as some kind of interface, because you might have different endpoints. So this is gonna be the generate endpoint. Okay, let's so yeah, I guess fine. Let's go in here. So we are gonna have a type image generator, is it like interface, and it's gonna have generate. This is the same as the LLM. I would still add the context. And now it's kind of interesting. So do we want because what if some of these interface, like some of these implementations have different requests, right? That would be my thingy, but whatever. So we are just gonna say simple prompt is gonna be a string and it should return bytes, like a byte array. I guess like this. We might have to see if we have a data structure for the image. Golang image data structure. Do we have an image? I guess if it's in standard library, it's perfect. Okay, I guess. I mean, it's gonna be an image PNG, so that's good. The only problem is, I mean, we have to rename this to something like image gen. Even though I said I don't like the name, but right. And then we might be able to say image dot image. So we might just return the image. But do we have PNG? Not really. Okay, then we just keep the image like that. I'm curious if we'll be able to display the image in the terminal because I'm using Kitty. I think I'm using Kitty, yeah. So is there, okay, ICat, right? So it's able to display images. So I'm curious if it's gonna be able to do it in here. That would be kind of nice. Or, I mean, at least save it in a file or something. Okay. So this is gonna be the base image generator. Nice. And we might have something like simple.go. This is gonna be our really simple API, right? So package image gen struct. So this should be similar to how we implemented Olama. Oh fuck. What did I do? Okay, whatever. So as I said, it's gonna be similar to how we did Olama, but it's gonna be like simple. And we need the base URL and HTTP client. So it's gonna be really similar to how we initialize Olama image generator, new simple, okay, and now it's gonna complain that simple doesn't implement generate. So let's copy paste this function. Let's say function. Curious. Oh, okay, so I said let's do simple. I was debating in my head if I'm gonna use S or G for the, okay, whatever. Okay, let's add context. I'm not sure what the best, like the most idiomatic VDM, VMT, okay. Right. So here at this point we have the base URL, we have the HTTP client, we have the prompt, we have the return type. It should be pretty straightforward. Let's just add the API. So API generate is going to be just generate. Okay, nice. So next step, so it has kind of a body in here. Right, so I might want to rename it from just the prompt to something different, like request. All right, so we have here types.go. Let's say we have generate request. It should have just prompt. It's gonna make things simpler. So it's inside of the package image gen. Perfect. Let's go back to image gen and let's say that here we have the request, generate request. Okay, so we have the generate function. Okay, then let's copy paste this part. I guess it makes sense, like image. What I didn't do in here, yeah, okay, fine. I should have done something like this here as well, but whatever. Right, let's just do to do return proper error. Is that how I spell it? I don't think so. Proper error. Okay, so in this case it's gonna be like image. We need to include Scufris. Let's do that. Hopefully we are not gonna have like circular dependencies. Okay, so here it's image gen error failed to marshal request. Failed to marshal request. Fair enough. So let's see what we have to do next. We can create a post request. Here we're gonna use base URL plus API generate, and we're gonna send the data as a body. So here we have the image gen error, failed to create image generate request. Good content type, yeah, sure, it's JSON. I accept should be image PNG, but I think it's gonna be fine. Let's do the actual request. So here is gonna be simple HTTP client, image error. Let's still copy paste. Failed to make image request. This is generate. Okay, and then with the response we have to do some stuff. Now that's gonna be the interesting part. So right here we are just doing read all. I think that's fine. Read it as bytes. So we have byte array. All right, we still have an error. Failed to read image generate response. And then with the response body, which is a byte array, we have to do some stuff. But let's check the status code first. Okay, so here it should be image gen error, generate. Fine. So how can we can we have some kind of image in your RGB? But really, it's pretty basic what's inside of here. I guess we can just let it as return image and nil for now, and we might see if we can somehow save that file. But all in all, this would be the image generator. So to use it inside of our tools, tool image, I would say that instead of this stuff, we might want something like gen is going to be image gen image generator, right? So we imported image gen, we have the generator, so we can pass it in here. Gen. And when we want to create a simple one, we just pass in the base URL, and that should be it. Right, it's gonna be localhost 8080. Yeah, localhost 8080. Okay, perfect. So we have all of that. Let's just fill in the rest of the things. So this is going to be image tool parameters. This one is kind of scuffed. I haven't found a better way to do it, but whatever. Image generation. Use this tool to generate an image using a text prompt. Important, the prompt must be a valid string. Whatever, that looks fine. So let's have the call tool parameters. We're gonna say this should be image tool parameters prompt, and in here I would just I would still keep say. I need to check the image generation. I need to run the image generation tool with prompt, and so it's gonna show us the prompt that it's gonna use, and then we just need the image and the error from the generate, but it wants a request. Generate request. I think for the types I have a new function, so I can just reuse this one. For instance, new generate request with the prompt. Right, I think that looks fine. Tools image, so we have generate, new generate request, and we just pass in the prompt. Now, sure, fair enough. We could have just made it so that you have to pass just the prompt. It is what it is. I think for the agent we have to do the same thing, new chat request, but it has a lot of parameters, so that would be uglier. But for the image, who knows, maybe you want to pass in some other stuff as well, I don't know. But then it's gonna be interesting. How do you know which structure to use, right? So that's gonna be interesting to figure out how to do. So right now we are just passing here the interface, but the interface has this request parameter, which might be different from case to case. So yeah, okay, whatever, we'll figure out how to do that. But for now we just get the image back. Right now it's empty, it's not gonna have anything. So it would be interesting how we can do something with it. Image. So the name is image generation. But what about the response? It's kind of nothing in the response, so that's maybe status success, I guess. But what's interesting as well is that if we fail, okay, I haven't thought about that in the weather tool or the other tools, but if you fail the call, you get a nil back, so you get a null. And inside of the agent, I guess if you have an error, we don't really care, so that's fine. Okay, whatever, it doesn't matter. So here we still get the image, we don't really use it. Oh, I'm missing the context. Right? So how can we use this image? Can we go blank bytes to image? Do we have something? Convert to an image. I mean, sure, we get that. Image decode. Oh, so it's called decode. Interesting. Decodes an image that has been encoded in a registered format. Okay. So we could just use this. So image byte, it's expected to be like res body. Right? So that way we get the image, and if we have an error, then we can say something like image and error, failed to decode image, failed to decode image. Image JPEG. Then we can save it, but let's move this logic. So this client's purpose, or I guess objective, is to just call the endpoint and return the image. So we don't want to save it here. It's more like it mimics what this page does, right? So it doesn't save the image actually. So it's just making the request, returns the image. In case we have an error, it returns the error. So we should do the saving inside of the tool image, in case we get an image, right? Move this better. So right now, you can just import it. Save it as a JPEG, but let's save it as a PNG. Don't really care about options. Interesting. Yeah. It should be something like, okay, JPEG encode, okay. PNG.encode out image, is that all? And it can return an error, obviously. Okay, so in case we have an error, we could just return null. Skip that. So this would be image tool error, failed to save image. So this entire thing shouldn't be really needed, right? We want to display it somehow. We would like to display the image and maybe even encode it in base64 and return it, because there are some models in here. So this lava model is able to get an image as an input, as a base 64 encoded string. So if we encode it as a string, we might be able to use it in the history of the agents, right? So that would be cool. But the important thing is to display it somehow. Okay. So let's see if we go to main. Let's try to add a tool, new image tool, and this one wants image generator. So let's go up here and create image generator, new simple, and just like we have Olama URL, we should have image gen URL, HTTP, localhost 8080. And I mean, it's pretty cool that we have everything hosted locally. That's pretty cool, not gonna lie, that's insane. Image gen URL. Maybe in the future we'll just add logging to it, but right now I don't really care. So let's go ahead and do image generator. What? Okay, perfect. So that's just adding an extra tool for generating an image. Nice. Let's see if we can actually run these things, because you know it's gonna load the LLMs into memory. It has to run also the image model, so we'll see if it's capable of doing it. Generate an image of a cat. Let's see if it's gonna do that. Oh, I guess it ran out of memory problem. Let's see. Okay, it ran out of memory. I'm curious if it was, I mean, probably it was because we run both the LLM and this model in parallel. Can we hack something together to make these work? Not sure. I like how it actually killed the chat for some reason. I'm curious why it killed the chat though. Let me see. Because if it gets an error, for instance, let's say it got an error from a tool, so it should say image. Okay, even Firefox died. It's cool. Hopefully the recording didn't actually die as well. But I'm curious why the chat died. Tool call error. One or more. Okay, so it's in the one or, okay, here. Okay, it's because when I was when I just started and was doing this thing, I wasn't actually returning here if we had an error, and that's why it still kept working. And now if we check main, I'm actually, if you get an error during chat, it closes it. Maybe I want to do something like continue here, but I don't really care, honestly. You shouldn't have errors. Okay, so yeah, that's pretty sad. So Can we use a smaller LLM? Scufris. Let's say we use llama 3 and let's load just the image generator. I guess I have to restart this. Is it actually going to free the memory? Looks like it is. Because I'm also, if you notice this, if you enable model CPU offload, it's using less memory because it's putting the model on the CPU and it's not used, but no idea how I can free the memory itself now. Or I guess now since the yeah, okay, let's go to Scufris, let's kill Olama. Let's do, I think I need to still run Olama. Okay, Olama create Scufris. Let's recreate it with a low memory usage with llama 3. Let's try to rerun image generation. I mean, it's gonna use something like 6 gigs of memory from what I've seen, from what I tested, the image generation. So hopefully Scufris with llama 3 is gonna use much less. Okay, so it doesn't like that I haven't used these guys. Let me just comment them out. Okay, generate an image of a cat. Nope, still too much memory. Okay. Can I run? Okay, so let's try something else. I know it's possible to run Olama on CPU. So let's try that. What if we run to, my god, that jump scare. Olama CPU. Fuck. Let's try to see. Olama help. Do we really not have, because what I had to do in the flake was to have here Olama CUDA to make it use CUDA, but how to run Olama on CPU? But we should be able to. I mean, the easiest way would be to not install Olama, but to do Olama right. And if we need develop, hopefully it's not gonna take 10 hours to install it, but okay, nice. So we do Olama serve. no compatible GPUs were discovered, right? So now if we run this thing, generate an image over cat, it should run on the CPU. So it shouldn't crash the other model. Let's just check it. Okay, so it's running. It did run, in fact. It's gonna say, okay, here's the here's the image, but it's not there because it was saved. So if we check image PNG, the fuck is this shit? I guess it's an image of a cat, but whatever. Now, so crisis averted. It's sadly it's not gonna work. I mean, maybe hopefully it was just because I'm also recording and that's using some GPU, but it's probably not. But I mean, it's still running even on CPU decently for Llama 3.2, but I'm pretty sure that Quen doesn't work, and we're also having to give up some tools. But I mean, these tools are they shouldn't matter that much. We should be able to run with them because it's supposed to not use them. Like if I ask it generate an image of a cat, hopefully it's not gonna call to weather. Like, why would it call to weather? Okay, nice. So it's running the image generation tool with a cat. I mean, it's such a such a lame prompt, but whatever. Okay, that's cool. Nice. Now, what would be kind of interesting is whatever, you still generating the image, right? What the hell? That, I mean, it looked pretty cool, but yeah. Okay, anyway, so what would be nice is, so here we get image. Can I do something like Golang image to base 64? Converting images to base 64 in Golang. Okay, what the fuck? Uh-huh. So we might find something like base 64 and then some kind of function. Let's see if we can actually find that. So base 64 dot encode, new encoder. Interesting. JPEG decode, we get the image, then we create base 64 standard encoding, encode to string, and it needs some bytes. Okay, that's interesting. And the data, image, but what did it do with the image? Who knows? Okay, interesting. So I did, okay, so if we go to simple, here we decoded the image to a structure. Apparently it's not really needed, we could have just returned the bytes, but honestly I would still keep it as an image. I don't know why. So we might want to turn it into bytes. So png dot encode, png dot encode. You know what, maybe here we should just return byte array, because if you think about it, the response from the API, it's kind of bytes, right? It's like a binary response. So I think it's fine to not have to convert it to image. I mean, we know how to do that. It's pretty simple. So let's just return the res body, like the bytes, directly. So here we're gonna do, let's still call it image, and we return that, the res body. Okay, whatever. So we are not converting it to an image anymore. Okay, so generate is gonna give us some bytes. So this is gonna be like data. So instead of doing all of this stuff, like saving the image and stuff, I mean, it's still fine to save the image, but again, I'm curious if we can actually, so here we get the image, encode to string data. Nice, this one doesn't have an error. So we get back a string. So let's try to do something here. Image. So it gives us the image as a base 64. For a PNG. Right. Now, kitty display image from int base 64. Maybe there is something. How can we show an image? Image to blob. Okay, this is C code apparently. So we base 64 encode it, and then what if we printf it like this? Right, like it should be some kind of code in kitty to show the image. But I mean, I'm pretty sure about that. So let's try it. So let's do fmt.printf, and this is gonna be similar to how we do it in verbose, right? So we just do printf, fmt printf. We are printing some stuff. Oh, actually, let's add a function in here. So it's gonna be function ICat, right, for printing the image. And then we have the image as a string. It's a base 64. And we have, see, like converting it to an image, maybe it made sense because now we need these things, but we kind of know what's the size, right? So if we do file on image png, we know it's going to be 124 by 124. So we can just hard code it for now. We'll figure out how to do it later. Right, and then we have to fwrite. the string, so fmt print image, and then we have to print f this thing, and then maybe it should be fine. Okay, so here it doesn't like EU. So here we can do verbose dot ICat image. Let's see if that works. Generate an image of cat. No, I'm curious, is is that gonna be it? I guess this has more stuff, but no. Who knows? I mean, obviously, if you want to see the image, maybe you should have like a web app, but let's see if this thing works. Or is it hanging? Oh. Okay, so it won't work. Okay, interesting. So we might want something like this print chunk. Okay, then let's try that. So inside of ICat, we want fmt.printf, and then we have, oops, still these two, 124 by 124, but it adds some m equals 1 or whatever. And then it's doing a while loop while length is greater than 0, but we already know the size. Right, we know the chunk size is gonna be 4000, so I guess chunk size is gonna be this. Total size is gonna be 124 by 124. Okay, and steps is gonna be total size divided by chunk size. So we can do something like for I in range steps. Oops, the fuck? Okay. We need a chunk. So the chunk is gonna be image. Can I do something like I times chunk size up until I plus 1 times chunk size? Can I do that? Chunks size. Okay, I can do that. Nice. And then you have to use something like this. To right equals to chunk size. I think 124 by 1, yeah, it's gonna be divisible, so that's fine. So we want something like this inside of a printf, fmt.printf, and I is always gonna be 1, maybe. So we print f that, we get the chunk. We have to write the chunk, so fmt print chunk. Then we have to clear, and I think we also have to, no, we don't. We can just print a new line at the end. So, new line. Is this gonna work? Let's make some bets. Generate an image over cat. So it's like chunked. I mean, it kind of makes sense, you know, like, hopefully. But we might want to use it in a separate, like not to use it with the LLM if we see that it doesn't work. Kind of weird. Oh shit. So we kind of need m equals to 0 at some point. I can't help with that. Okay, fair enough. Okay, so should we try to do with 0? I mean, what I guess I'm gonna do is go to main. Let's create testing. Let's create a new main.go file. All right, so this one, it's supposed to do something like verbose, ICat, and then we need the image string. So if we go to image tool, we'll read image from, I mean, it's probably, I mean, let's just copy paste things. We don't really care about them right now. Okay, so here image, or I guess F. Sure, let's do it as image. Image is get image from file path, and we have image.png. Let's say we ignore errors. So what can we do here? I mean, we could have also did read all. F. Alright, just to get the bytes, because I want the bytes. And I don't really care about the image. So we get the bytes. And then in tool image, we did base 64. So this is going to be data. Here we get the image as a base 64, and then we can just pass it in. Let's just do a println at the end. So if we go run testing, let's the fuck. Oh, so we have a FMT print chunk. Okay. Oh my god. Go is such so annoying because you cannot run unused variable. It's an error. It's so annoying. Okay, so it's 256 lines, so that's good. Interesting. Let's search again. Kitty base 64 printf image. Yeah. I mean, that's kind of not what we are doing, but let's see, maybe they have it in the kitty thing. Not, it's not what you think it is, neofetch. Mm. Question is, how does it work? So transmit png. Okay, nice. So let's see it in Python. So we have some kind of payload. Okay. W is answer.append. What the fuck? Who do that? Whatever, doesn't matter. So it's this G thingy. CMD. Dude, what the fuck is this Python? That's what I'm saying about Python code, is that it looks insane, honestly. Join. Okay, so serialize gr command. Where is this thing used? Here. So this thing has payload equals to chunk, m is equal to m, and then the rest of the command. Data, here it's encoding the data to base 64, while data it chunks the data with 4096. M is 1 if data, else it's 0. That makes sense. I mean, we are kind of doing that here. Then it calls to write, then it flushes, clear. Okay, let's see what it does in here. So serialize gr command. It pops the payload, so we have M left inside of CMD items. We also have A and F though. A is equal to T and F is equal to 100. A is equal to T and F is equal to 100. Okay. So inside of CMD, we're gonna have some A and F and M. AF. AF and M. Interesting. Then it writes this thing with G, like we did here. A is equal to T. Nice. F is equal to 100 here. Not sure what 100 is for, but let's use the default. I guess it's the, you know, pixels per something. Then data. It doesn't have S or V. That's interesting. Anyway, so it does that. Then if we have a payload, it puts a semicolon, then it writes the payload, and then it does the 033. Oh, I had here M equals 1. Okay, let's do it like this then. So let's not include. Should we include that? I'm not sure what F is. But anyway, let's ignore the F. Why doesn't it do width and height? Not sure. So let's do it like this. A is equal to T, F is equal to 100. G, that's cool. Semicolon. Here it does M is equal to 1. Then semicolon. Then payload. So we should do M is equal to 0 on the last step. So here I should do something like if I is equal to steps -1, else maybe like this. So it's gonna be A is equal to T, F is equal to 100. Then we do 33, B. Then we print 033. Then we return the answer. We print it, we go again. Like we go again, and we have to print this thing again. So here, we need to print it every time. Key value or whatever. F100 indicates PNG. Okay. So let's see if this actually works. No, it doesn't. You know what? Let's copy paste this Python script. Let's go here, test.py. So if I run this thing with, if I do python 3 test.py image png, doesn't work. Maybe it's something to, oh, like that works. Jeez. Okay, so it should have the image. Indicates PNG data. The PNG format, RGBA. Okay, so if we do 32, we have to specify the image size. Let's try 32, and then it says here S is equal to 124, V is equal to 124. Nope, still doesn't work. But ICat did, so that's weird. In this format, any PNG image can be transmitted directly. Okay, let's see the... Oh. Let's see the bash example. Okay, so if we run this thing, like bash test sh, maybe I want to chmod test sh and then run it like this. Fuck. But okay, maybe it's because it's inside of tmux, so I'm gonna give it that. So let's go into personal Scufris. Let's do next develop. Nope. Python. Let's run it on the image. Nope. But if I run it with Kitty, it works. Okay, that's annoying. I like that here it says that it's also possible to what, send the entire image. The S key. Let's try to use the S key with 100. Maybe it's compressed or something. Oh shit. Okay. So maybe it was compressed. But here it doesn't work. So it is because it's inside of tmux. Or maybe it's because of the side of the screen. Nope. Okay, so we have something. It's because it wanted that. Oh, what the fuck? It's because, first of all, it was missing the S. Nope, it's just because it was inside of Tmax. Okay, fair enough. So then we can just take this and try to put it in our Go. So verbose, not here, verbose here. So let's see. So what's the difference? So we have 33G, A is equal to T. It should work, I think. So what if go run Scufris. Let's try to run Scufris. Generate an image of a cat. So let's see if it's actually going to display the image in the terminal. Wait, I could have run it on testing first, but whatever. Let's see if it works first try without any changes, but from the... I didn't. So it's still missing something. It's still missing something, I guess. So here it's doing 33 underscore G. Then it's doing the parameters, so A and F. Let's also do S is equal to 124, whatever. And then another comma. Then if data is empty, so maybe I'm wrong here. Maybe it should be always... Oh, what the fuck am I doing? It's just M. It's just M, right? It's just the M thingy. But I was like, what if I do M is equal to 1? And then M is equal to 0. And then empty. Nope, what the fuck? Oh, I'm missing the semicolon. Nope. Excuse me. No, this shit's crazy. Okay. Percentage D, and let's use here M, and then do something like M is equal, if I is equal less than steps, steps minus 1, M is equal to 1. What the fuck am I doing? M is equal to 0. Let's actually not escape anything. I'm curious what this thing looks like. Is it what I expect to see? Kind of, yeah, honestly. Okay, bro. Let's remove. Let's remove the escaping from here. I'm curious to see if it's. Huh, okay. Oh, okay. Interesting. So it didn't put the A and F anymore after the first call. The fuck, how did it do that? CMD pop? The fuck? CMD clear. Oh my, that's what I'm saying about fucking Python, dude. It's such an annoying language. So it made it like GM. Okay. So here it could be like this. AT and F. So for sure. Let's do it like so that it works. Okay, so here I can do m is equal to 1. Bam. M is equal to 1. Then, instead of doing the entire thing, okay. Then it prints the chunk, but sometimes it also has to do it with this kind of stuff. Like this, I mean. Yeah. Okay. And then it prints it and it prints that. But for the first step, we shouldn't do this. So if I is greater than 0, then we do this step. Otherwise, it means that we already did the first one and we don't need to do it. Then we print the chunk and then we have to print the clear. Let's not put the S. Okay, what if I remove those? That. Oh, I meant to also probably remove the chunk. It has more steps though, what the fuck? But the rest of the things look the same. So m is equal to 1. Yeah, the rest of the stuff is the same. So 496, what the fuck did I do wrong? 469 steps, or I guess 468. Really? What? Python 4, I need Python 4 for this shit. 124 by 124. And if we divide this by 469, okay, then how the fuck does it have 400? Oh, I'm so fucking dumb. It's because total size is the length of the image. I mean, probably someone was yelling that, but oops. Okay, so now it looks like the same length. Jeez. Oh my god. No joke, this shit's gonna make me go insane. Bro, it must be the same shit, right? What the fuck? I want to see something else then. Like, let's put here 033 because that's the escape code. I want to also see the escape. And then here. I forgot about the still a bit smaller. What the hell? It's like one smaller, right? So it's missing something. Okay, understandable. So if we go here, then let's no longer do that. Let's do 1. And let's do 0. So now this thing looks like that. And it needs the extra 033 at the end. So now it's the same thing. Exactly the same. Okay. So if we do the escaping back, okay, and we run it with go. Fuck. What? Ah, still don't get the image. Oh, because I forgot to print the chunk. I mean, hopefully that was the reason. Bro, this shit's insane. Really? Okay, let's actually print it with payload. Okay, I'm going insane. Let's print it with payload and escapes, and let's compare it directly. Like, what the fuck? So we're gonna have this thing into a file, a.txt, And then we're gonna do the Python one into b.txt. And now let's diff A and B. Problem is that these are one line, so fuck. I have an idea how I can solve that issue. Let's do a printf new line after each chunk. Why not? So that means a print here. And now if we diff them, okay, what? Okay, I mean, it looks like it's lines, and B, it looks like it's more lines. So after gm is equal to 0, it puts something else. Interesting. Oh yeah, okay. So it was in fact, if it's the last one, then do m is equal to 0. So m is equal to 1, and then if I is equal to steps, then m is equal to 0 or something. Right, so in fact it was that. I guess it's m minus I steps minus 1. It still has something extra, but I don't get it. Like it's the last step, what the fuck? So last step should be the one with GDF. But this one has an extra one, what the fuck? Okay, bro, I forgot about the plus one probably. It wasn't the plus one. I mean, here it's already I plus 1. So it's going from 0 to the last chunk, but do I have anything left at the end? So it's that big, right? Divided by 496. So it's something plus something extra. Okay, something plus something extra. So it's the extra stuff that I need to handle, I guess. So can I do something like chunk is equal to image at steps times chunk size up until the end, and then print it somehow. Yet. So a.txt ends with this gd. A has some more stuff. I mean, it has this extra line which I don't really care about. Let's just remove it. Why do we have this extra thing? IV. So what's the difference here? A is equal to T, M is equal to 1, A is equal to T, F is equal to 100. I don't see what's different. I guess I forgot to put a new line or something. Yeah, okay, so it should be fine now, I would assume. Like I probably forgot to put a new line. That's what I think it was, at least here. Wait. So here I'm printing this. Yeah, I forgot to put a new line. Where did I forget to put a new line though? I guess in the Python file. Okay. So it doesn't matter then. So let's do here backslash. Jesus Christ. I mean, if this works, insane. Finally, Jesus Christ, this, I mean, this has to be the worst fucking shit I had to write. Okay, I mean, kind of makes sense now. I guess it was good that I found the documentation after all. Okay, perfect. So if we try to run it though from here, it's not gonna work because it doesn't work in Tmux. Okay, good to know. So let's run Scufris, generate an image over cat. So if we run this pipeline, now we should see the image in the terminal. So that would be really cool. I mean, the only part that I'm kind of sad about is that it doesn't work with both the LLM and the image model on the GPU. That's a bit sad, but whatever. So that's pretty cool that it actually shows us the image in the terminal. But yeah, like we cannot run big models on CPU. We have to do a llama 3.2. But yeah, I mean that's cool. And obviously this feature doesn't work on other terminal emulators. So it only works in like Ghosty, Console, ST, some other ones that I haven't heard about, but yeah. I mean, it hasn't finished yet, or is it just maybe missing a printf here? Maybe I need to add a print line. Okay, whatever. So I can't fulfill this request, but I mean, it kind of got the image, right? Not sure how we can make it actually display the image and say something like, okay, this is the image, but whatever. Maybe it should be, as I said here, maybe we should have actually an agent for the image generation, and that agent is supposed to say, okay, we generated the image, we displayed it, don't worry about it, tell the user that everything is good. So something like that, right? Like an intermediary between the image generator and the Scufris. But yeah, I mean, it works. Again, what I would probably like to do is remove these things, remove testing, so we don't need testing anymore. Image PNG, we don't need it. We don't need these two. We need those. Modification. Oh, I guess modification in main Go. It should be just the image gen, the URL, adding the new image gen, and adding the tool. So that's all we changed. Right. In Llama, return the proper error, I'll do that. Then for model Scufris, I still want to use Quen, although I don't think it's possible to do on CPU. And for verbose, maybe I want to refactor this, but who cares? It's honestly, if it works at this point. And for the flake, I still want to try to use CUDA. I'll have to figure that out, but yeah, the rest of the code should be good. Implemented image generator. So yeah, that should be all for today. Like we managed to, I mean, I implemented this one off screen, but it was just copy pasting from the docs and running it in a Docker file because I couldn't get it to run on Nix. If you have any ideas on how to install Python packages faster on Nix, please share that stuff, because for me it took like 2 hours and I gave up on trying to install the packages. So yeah, if you know how to install PyTorch, diffusers, things like that, please help. So yeah, and then on the Scufris side, we just added a tool which was just a web client, HTTP client for the image generator. So yeah, that was the entire idea. Obviously we spent like a lot of time to implement ICat, but whatever, it was worth it in the end. Even though it doesn't work in Tmux, I'm not sure. I envision this Scufris tool to be something like, not even sure, in a different terminal window, so it's not gonna be using Tmux, but you get the point. So yeah, that was the entire thing that we have to do, or I guess we had to do. Implement the image generation tool to run locally, and then call it from our pipeline, right? So we actually got that. The only sad part is we don't have enough GPU memory to run both of them at the same time. So we have to put one of them on the CPU, but you know, maybe we can change that in the future, who knows. Maybe we can use like a paid service for the LLM, or I guess for the image generation, but instead of localhost. Okay, so yeah, I guess that's it for today. So yeah, don't forget to, you know, if you want to check out the projects, they're gonna be in the description. So until then, I'll see you.